Hello, everybody. It's me long again. Hey, it's been a long time, eh? Honestly, it was so busy to find myself just a little time to do my favorite things. You know, just talking like that, talking to you, sharing information, sharing my knowledge to everybody in this world. Yeah, responsibility, eh? Sometimes you gotta do the thing you don't like because you got a responsibility to another person. But yeah, I hope you're doing well. How you doing, my friend? How you doing? So yeah, I hope you're doing well. And eventually, we're here today, right? We're here today. It's Melon. I'm back, and today we got the lecture two, data acquisition, part one. So, are you all ready, my friend? I'll go right now. Just a little bit. Let me see. We got a basic principles of city in the lecture one. And today we're going to lecture two, data acquisition. That means we will go more detail about our city system, computed tomography. So let's start, right? First of all, I want to introduce you to gantry. Is anybody knows what is gantry? Yes, you're right, my friend. You're right. Gantry is a ring shape, a circle, you see, on the picture right here, a circle if you look from inside to the outside. So, but the point is, I think, yeah, that's just gantry. Yeah, that's it, gantry. And sometimes people talk about gantry, the most popular thing, two popular things about gantry. I will show you right now. Just give me 30 seconds, right? I wanna turn on my fan because it's too hot in Vietnamese in Vietnam right now. 2 seconds, my friend. 2 seconds. All right, I'm back. So, two most important things about gantry. First of all, the the angle, the tight angle. It's just simple thing. You know, the gantry. You wanna change the angle. You wanna up up and down, yeah, depends on the patient, depends on the application you want to use on the patient, right? And that's simple. Sometimes you see, I just want to mention it because in case you saw it in the past on a configuration document of some CT gantry. So that's just a simple thing. The second most important thing, maybe the famous thing about the buzzword, if you want to talk about gantry, what is it? The size, my friend. The size, the ball size. Everybody talk about ball size. Even in MRI, they just take care about ball size. Yeah, in MRI, if you just have a chance, I think it's a yeah. I think you all heard about that the ball, right? And in many cases, in MRI, exactly, they divide MRI levels. You know, levels mean the high end, the low end, yeah, the middle, by the MRI ball size. You mean that? The MRI balls are two typical size. First of all, 60 centimeters, and second of all, 77 centimeters. So just like the same for CT, but the point is right now, it's more complicated because yeah, it's absolutely CT have two most typical size of ball, 60 centimeter configuration and 70 configuration centimeters. But yeah, I just remember the time. Just this time, my friend. Once one of my students asked me about GE and Sysman about the 32 slices model. GE 32 slices model ACT have only 60 centimeters ball size. But on the other hand, the Sysman model it just made 22 detector array. The yeah, 22 the 32. I hope so. The yeah, that's CT. They have 70 centimeters ball size. So, yeah, absolutely, you can see that everybody, every patient wants to be in a bar that are big, right? Everybody wants to be in something big. They're comfortable, and sometimes claustrophobia makes people uncomfortable, inconvenient in a bar too small. But my friend, not like an MRI. This time, computer tomography ball size. GE said in this case, the bigger ball size is maybe not the optimal one. Why? Because the radiation dose of the CT won't, let me say, increase proportionally with distance, the square distance from the tube to the patient. So what does it mean? It means if your ball size is bigger, your patient will take more dose of the CT, of the X-ray. So yeah, there's a little interesting thing about the size of the ball, size of the gantry. I want to share with you right now. Just 2 seconds things, right? And yeah, in Vietnam, they I don't think there's a problem with 60 or 70 centimeters ball size because yeah, the size of the people, size of the person in this country is not too big. You know, the South Asian, and yeah, maybe there's one thing I want to share you today. I just remember the second, the first time I go with my colleagues, but this time I was a sales, I don't know, I was a broad team, and I got a chance to go out with my technical team. Yeah, my technical team. So they are engineer, and they help me. They want to show me how the inside of city. So you hear right? The third picture. The reason why I put it on here because it makes me just remember the first time I see it, and as over time, along with this section, with this session, with this presentation, I will show you a little bit a tricky pick, and I will show you the things about the detector, the position of the detector, and the generator, and the tube. Yeah, just remember the first time. Memories. Oh my god, beautiful time, my friend. Young fucking curious mind. Yeah, just excited about everything. So that's the first one. Let's go to the second one, eh? So the next thing the first thing we wanna talk about in the gantry. Next thing is about slip ring. So I think everybody of you heard about slip ring once, right? Can you tell me about that a little bit? Slip ring. Yes, my friend, you're right. Slip ring is a kind of technology related to, how can I say it, modern CT models. Why? Because modern CT models have the continuous rotation of the tube, my friend, and that is because of the slip ring. Slip ring take account for that. Thanks to the slip ring, the tube right now don't need a cable to generate to no, I'm sorry, don't need a cable to, how can I say it? Don't need a cable to for the electricity to move. Can you get that? Can you get that? Yeah, we don't need a cable connected directly to the tube for the electricity to move anymore. Right now, we just need a slip ring, and they are separately two part, no cables at all, no cables at all. And that's the reason why our tube in the gantry can swing, rotate forever in one direction without going back. Without going back, my friend. So for instance, just look at the first picture. This is the first generation of CT. You see that? The Genji, you got a picture right here, and you want to go the next thing. Beam off, my friend. Let me zoom out picture. Beam off. Move the table. Move the table. But the tube, my friend, just need to rotate on the reverse direction. They don't take that. Just remember, yeah. The tube need to move on the reverse direction. So and since slip ring right here, we right now the tube don't need to move in the reverse direction. That's the reason why we got a continuous table movement right here, and that's the reason behind a boost rod in the modern CT model mode. Helical CT scan, my friend. So altogether, I just wanna one note, one conclusion about slip ring. Slip ring is visual technology related to the modern CT models because it helps CT models in the modern world can rotate that tube continuously. Just like that, my friend. Simple. Take it simple. It's because simple is the goal of this whole lecture. Alright? That's all about slip ring. Whew. Well, alright, let's go to the next thing. Let me see. Oh my goodness. Generator. Oh, there are many things about generator I want to talk to you, want to tell you because it's not all about technological things, but aspect about this thing. Yeah? And when you are the product or let me tell you a story, right? When you are a product or some modality, and I wasn't the product specialist of the CT modality of a manufacturer, quite famous manufacturer in the past. And sometimes, my friend, sometimes the generator as a product specialist, you gotta you gotta explain the configuration, explain the number, the implication of the number behind that. So, and the generator is some kind of it's just one of the parts. Just memories. Oh my god, memories, my friend. So let me tell you something. Let's take a quick look about the definition of a generator. Generator, what is it? Simple, my friend. It generates electricity. That's all. But maybe you just don't electricity and I want to explain more detail about that. How electricity from generator can affect the X-ray beam of the CT. How can? So the reason behind it is simple, right? Do you remember the time I show you? Let's go to the Google, right? No, I'm sorry, it's a private laptop, so I can't go to the Google. Maybe I think I can get a pen right here in case you can get it. Just maybe I can talk slowly, right? I can talk slower so you can get it. So back to the question: how electricity from generator affect the X-ray tube? So do you remember? Hey, oh my lord, we got a picture right here. Hey. So yeah, we see you see right here. We got an cathode right here. We got an anode. We got a and high voltage source here is the generator. All right. So we got an electron beam hit it. And you got in here electron. Can you see that? Electron, my friend, electrons. Electrons is the electricity. And the electron got a bombard the anode. And from this point, X-ray beam is created. Yeah. And how the electron beam affect the X-ray quality or the quantity? So it's simple. Let me see. The generator will create the electricity, right? So it is represented by the power kilowatt. kilowatt, right? And kilowatt and power is could be divided two parts. First of all, it's a kilovoltage of the X-ray beam, kilovoltage of the X-ray beam, and it show you the energy. It represents the energy, and ampere settings. It show you the numbers, the quantity of the electron. Kilovolt is a quality energy, and MA is a quantity. All right, and two of them, all of them affect the X-ray beam just like the same way, right? That if you got a higher kV settings, you will create the higher energy X-ray beam. And if you increase the MA setting, milliampere settings, but you just keep the same kV, you will create a more intense, my friend, more intense X-ray beam, but not higher energy level each photon. Yeah, just like that, so you just remember this, okay? Generator is represented by its power, and its power could be controlled by two ways: kV settings and MA settings. kV settings represent for energy, and MA settings represent for the quantity, the number of electrons, the kV energy of each electron. All right, are we clear right now, my friend? I hope you just not too. Yeah, it's quite simple, right? It's quite simple right here. You don't. Just focus on my conclusion. You can take it back when all of this is done. You just roll back, listen to it again, and you got it, my friend. It's simple. It's easy. I mean, in the whole about whole scope of this presentation, we will focus only the simple things. All right. And yeah, the second thing I want to show you right here. Um, it's obvious. I think it's obvious. I want to talk. I just want to talk about it because I think, yeah, under my experiences, there are so many times. Sometimes the things seems like too obvious. Seems like the thing seems so obvious, but eventually when I ask a person, they can't get it. Yeah, but so that's the reason why I don't blame on them. I don't want to blame them. I just want to show that we gotta talk about everything. We gotta be careful about every single word we say. Uh, yes, and that's my responsibility to talk about everything related to generator. So as you can see, the X-ray tube right here, kilometer. We will go about it. We will talk about it in the last part of this session. And the detector right here. So obvious, the X-ray tube will be positioned opposed to the detector. And yeah, the high voltage generator is located next to the X-ray tube right here. Yeah, just want to note for you, and just roll back into this. Yeah, it's a reality of the CT inside the CT gantry. You can see, oh, right here, absolutely X-ray tube. Right here, detector array, my friend. Woo, look at that. Oh my lord, it's a really big detector, hey? And where is the generator? This is the generator. Oh, memory just memory just came back, my friend. Memory just came back the first time you see this. Woof. Ah, magnificent. Speechless. So that's generator. Let's go to the X-ray source. What is X-ray source, my friend? What is X-ray source? X-ray source is the thing create X-ray. And what is the thing create X-rays? You're right, my friend. It's an X-ray tube. X-ray tube. So right here we got we don't talk about only about X-ray tube. We will talk about also some traits, some characteristic of it. So first of all, I want to show you this X-ray tube. X-ray tube. This is a paradigm draw about X-ray tube, and this is in a reality X-ray tube. So let me show you. This is this is the anode, the cathode. You see right here, cathode. This is the anode, and you see, this is a rotating anode, just like this. You see right? Just like disc. And this is the target, the anode target. Its electron beam will bombard here, and the X-ray beam will be created from here. Just simple, right? All right, and yeah, just let's talk about the trace of the X-ray source. First of all, there are two most important things you gotta understand, you gotta know, you gotta learn by heart about the X-ray source. First of all, heat capacity. Second of all, heat dissipation rate. What is it? Let me show you, my friend. First of all, heat capacity. X-ray, electron, the bombard things, it will create heat. Why? Too much energy, my friend. Do you know the how can I say that? Do you know the efficiency of from the electron beam to the X-ray beam? Just 1%. 1% of electron beam can turn energy of electron beam can turn into the X-ray beam. You know that? 1%. So what is the remaining things? It's a useless. And what is a useless? Useless mean it will transfer into the heat. So that's the reason why our tube will be very, very, very hot. And because you want to take a picture all day, in some cases, maybe some cases in modern day, 100, 200 cases per day is just normal. And that's the reason why your tube, your X-ray source need to have high heat capacity. It means you can hold the heat into yourself as much as possible. Heat capacity. And the second thing, heat dissipation rate. Dissipation rate. What is it? Heat dissipation rate is simple. The ability of you could release the remaining heat in yourself. So as you may be, even though your heat capacity will be some enormous number, you got a really high heat capacity, but over time, my friend, over time, your capacity will be full, and you gotta wait for them, all of them, to get out of your body, get out of your tube. And what is the number to show the ability? That's a heat dissipation rate. Just imagine a bottle of water. Just like here, it's a metaphor of it. I think it's a good metaphor of it. That's the reason why I chose this picture. Alright. Just imagine, just a water bottle, right? Heat capacity is a bigger water bottle. It's a bigger bottle, larger bottle, more enormous bottle. And yeah, just like that, heat capacity. And the heat dissipation rate, just like the rate, the velocity, the amount of water running out from the bottle over time. Yeah, just like that. And yeah, I just wanna remind me the time I was the product specialist of that manufacturer, because our heat capacity of our tube, our CT model is not quite so big, so enormous compared to our rivals. Just like we got 5 MHU, and our rival got 7.0 MHU is 2 MHU, right? But on the other hand, our heat dissipation rate is higher than them. So what does it mean? Because eventually it leads to the same result. Yeah, the number of cases we can take in one day is equal to the number of cases they can take one day. Yeah, and we got an advantage. Why? Because because as the last one, I want to note here for you just the commercial part aspect of this section is the money you want to make your tube more strong in the capacity of heat will cost you very much about 4k US dollar for just 1 mhu heat capacity. It means focus in the heat dissipation rate just like our vendors. That time is more economic efficient. And eventually our model just lower price than the rivals. And yeah, we just ruled the CT market share in Vietnam that time. A little bit proud of my team. Yeah, just about that. Just about that. It's all about X-ray source. So what do we have? Oh my filtration. Hey, let's go to filtration, okay? Uh, does anybody have any question about X-ray source? You got 10 seconds to type a comment under below my YouTube channel. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, let's go to the filtration. Just get a question on the comment and I will reply you as soon as possible. Alright? So filtration, filter, right? Filter. I just because my book write it in the filtration word. I just want to write it filter to be simple, but yeah, we gotta respect our author. Filtration, filter. So what is it used for? What is used for? What do you use for you? How do you use the filter on a daily basis? Just have a fall, right? Filter help you to be smooth skin, right? Smooth skin or whiter skin, right? And let me say filter or red lips, pink lips, bigger eyes, thinner faces. Yeah, that's a filter, right? So the filter is the kind of, how can we say it in general? In general, the filter is a thing we use it because after that, after going through the filter, we got a result that we want. That's a filter. And just like the same apply for the same city, filtration in city work like exactly the same. But the point is, we gotta determine what is the thing we want in this case. So the point is, this case, the motivation behind the using of filtration is the demand of the monochromatic X-ray. Wow. Am I too fast? Am I too fast? Let me be slow. Okay. The reason behind of using filtration in the CT application is because really want a monochromatic X-ray. Yeah. All right. So what is monochromatic X-ray? Monochromatic X-ray is the part of yeah, they got another term, polychromatic X-ray. Just like here, I want to zoom out the picture for us to be more easily to be focused about it. All right. Yeah, monochromatic X-ray and sorry. Okay, nice. Polychromatic X-ray here. So let me get simple. Light, X-ray is light, kind of light, electricity, electrical waveform, right? Kind of light, and light have a spectrum, right? Means there are many photons with many, waveform in that light, single light. And our calculation, all our calculation based on the assumption that our beam is monochromatic means Our beam just has only one wavelength. Sorry, wavelength. Yeah, frequency, one single one frequency. Yeah, but in the reality, it's nothing exists like that. Light is a combination of a set of wavelength and frequencies. So that's the reason why we gotta minimize as much as possible the phenomena called so-called polychromatic. Yeah, we gotta minimize that phenomena. So that's the reason why we gotta use filtration. Yeah, and in the other hand, in the other word, sometimes you will heard about the term. Let me text it for you. The terms we are hardening the beam. Yeah, what does it mean? So if initially, the beam was soft. So you're right now soft right now means polychromatic. Too many wavelength, too many photon have a variety of wavelength, a variety of frequencies in our beam, right? And after going through the filtration, our beams right now is monochromatic. Yeah, just like that. Just like that, my friend. All right. Let's take it back. So, hmm, that's the first reason what behind the filtration. Maybe one of the most important thing, inhomogeneous in X-ray spectrum. The second thing I want to list right here is because our nature of our body part, the middle thing, the middle part is usually thicker. It's usually thicker than the peripheral part. Here, just imagine, right? Our chest body part right here. Yo, you gotta use your hand right now. Yeah, feel your chest, feel your chest right now. Okay, yeah, and it's really obviously thicker than your biceps, your hands, right? Your arms, obviously. So that's the reason why some people believe that we gotta we gotta change the situation. We're gonna decrease the dose of the beam, decrease the dose of the beam for the peripheral part, so that we can have how can I say it, homogeneous image data, right? So this is really I think it's really articulate demonstration about this thing I just talked to you. So this is the bow tie, one of the most popular filtration filter in CT. So bow tie filter, you can see that bow tie filter is just it's called a bow tie because it just look like a bow tie. So this is a bow tie filter, and you can see a new attenuation across the filter because this is thicker than the middle. So the attenuation on the attenuation of the tie of the bow tie filter, right, on the outside is higher than in the middle. Simple, right? And you can see that attenuation across the body in the outside will be smaller, than here. Why? As you can say, the outside peripheral body part is thinner than the middle part. So we use it just like that, just that, yeah. Okay, this is just like that. Yeah, you decrease sort of the outside of the X-ray beam, right? And after go through that, everything will be the same, right, my friend? Right? Can you get it? Can you get it too? Can you get it? Right? My friend, two main reasons. Let me take it. Let me let me have a conclusion for you. First of all, in homogeneous X-ray spectrum, and in this case, we use kind of material, aluminium material. All right, to minimize as much as possible the polychromatic X-ray phenomena. And the second thing, that's the reason why we need to use the filtration, because especially the bow tie filtration, because the nature of our body, middle body part is thinner. Oh man, is thicker. Oh my god, thicker than the peripheral part. That's all. That's it. Filtration. There's one thing about a couple of things you need to know. Filtration, two reason in a homogeneous X-ray spectrum, thicker body part of the middle, and the bow ties. All right, bow ties. That's it. That's all we gotta know. We need to know about filtration. All right, my friend. Can we move on? You got time, 10 seconds to note down your ideas right now. Honestly, as I remember the time. I remember the time was in college, and my teacher, my favorite, right? I really admired him about his enthusiasm in teaching stuff, and yeah, he's always energetic really energetic. I can't imagine that every day he's the same. Jesus Christ! And yeah, even though he is an energetic person, but we cannot, we're just a human, ordinary human. We can't just get all the ideas at once. That's the reason why we gotta read a book. Even though I got a really good teacher, but I gotta keep reading again and again the ideas in the book. And we ask him, but yeah, I think that even though you got a good teacher, you gotta improve yourself every single day. That's the point. But I think yeah, but I think you don't need to worry much about it, because if you got a really good teacher, you don't need to worry about that, because yeah, you may not understand right now, but a good teacher will help you understand it, help you over and over until you get it. So just take it simple, take it easy, take your time, think about that, think about everything with your joy, and yeah, feel alive, my friend. So that's it. Appreciation. Let's go to the last part of this session, my friend. Collimation. What a collimation! I really want to use this collimations. Kilometers. Yeah, just remember the time I pronounced it in my first videos. I pronounced it wrongly. Really, I'm sorry. I apologize. This time it's different. Kilometers. All right. What is kilometer? Kilometers is let me think about 5 seconds. How can I end with How can I end with a clearly precisely and but really short sentence about kilometer? Kilometers, my friend, is a part of the city which can control the X-ray beam width. That's it. That's it. All right. Yeah. I think it's good. I think it's good right now. I think it's good. Uh, so far I think it's good. Kilometers is the part of the X-ray system of the city system to control your beam X-ray beam width. That's it. That's it. No more, no less. Just it. Kilometers. So there are a couple of things you gotta catch up about kilometers. First of all, there are two kind of kilometers: pre-patient kilometer and post-patient kilometer. And sometimes there are people call it pre-detector kilometer, but I don't really like this term because you gotta be consistent all the time, right? Pre-patient or post-patient. And you, if you just say pre-patient and pre-detector, it's a mess. It's a mess. I don't want to be a mess. I don't want a mess in my mind right now. Yeah, so universal, right? It's a rule, private rule. Pre-patient kilometer and post-patient kilometer. Pre-patient kilometer is the kilometer put just under the X-ray tip. Yeah, like here. It's a you just see my mouth, right? The mouse. Yeah, it's a pre-patient kilometer, and the post-patient kilometer simple. Just located under our patient here, right here, right here, right here. And what is kilometer used? Kilometers is used for, first of all, reduce the scattered radiation. Mhm. Second of all, we it affects patient patient dose. And the third one, maybe the most important thing one, the kilometer control the slide thickness by control the beam width. And from that point, you control the beam width that leads to the patient dose be affected, and you gotta can reduce the scatter radiation. So this is the most important thing you gotta know, right? You gotta know, hey, you control the slide thickness by control the beam width. That's it. That's why kilometers used. So that's an illustration for you right here. How can I? Oh, I think it's a two picture in here. It's the same. It's the same application. So yeah, let me just pick it. Oh my god, it's too big. How can I use that? Bring to the. Can I bring to the front? All right, bring to the front. So as you can see here, detector right here. It's normal. It's not nothing change. Nothing change when you use a detector, single detector, and just like a conventional CT in the 19th century, 19? No, 20th century. But the point is, our modern CT models is a multi-detector array. So right here, it's a Z axis. Yeah, we have talked about it once, right? Z axis right here. So if you change the gap between kilometers right here, and you will change the way the beam behaves. What does it mean? Yeah, so just simple. You can choose, you can pick which ray of a detector array could be used. Just like that, my friend. And when we go to the detail about how detector arrays of a CT system works, I will explain you more detail about how we could change the beam width to have a variety of light thicknesses, and how the kilometer about pre-patient and post-patient kilometer used in a different way. Let me show you some example that I read from articles and academic articles. For the first time, I just in my memory, I hope my memory was correct. So in 2000, just approximately 2000 year 2000, the kind of uh yeah, this 8 channel 8 detector array CT of GE Philips. I just can't remember, right? Yeah. So if you want to in that specific mode, because each detector array just like 0.625 millimeters. So sorry, 1.25 millimeters. So if you want, if you want to have a slide thickness of 0.625 millimeters, how can you do? Yeah, you use the post patient kilometer. And the reason why, I think it's just a designation of the vendors. I can't explain it, but that's the point. Yeah, every vendors have their own designation, and the use of kilometer is the same. But the point is, we can apply each kind of kilometer in each case depends on optimal designation based on the vendor's strategy. But yeah, altogether, I just want to show you. I'm sorry. I just want to show you. I just want you to know two most important things about kilometer. First of all, two kind of kilometer: pre-patient kilometer and post-patient kilometer. Second of all, the main purpose of kilometers is control the slide thickness by controlling the beam width. Just like that. Just like that. That's it. It's the end of our meeting. How do you feel, my friend? How do you feel? Just tell it. Oh my lord, just remember the time was in college. Yeah, it depends on your teacher, I think. Uh, I was so lucky, friend. I think I was so lucky, so too lucky to have that kind of teachers. Oh, remember the old days, right? But yeah, time flies, my friend. And over time, it gotta be made. It gotta be made to take that responsibility, to share, to spread the knowledge that they did the same thing with me 10 years, 20 years ago. Yeah, you gotta take the responsibility. That's how it works. Memories! Oh my lord. Hey, I wish you have a good day, doing well, and we will go back. We will meet each other back in some beautiful, nice winter day. Alright? Take care of yourself, keep your body warm, and keep your mind healthy. Alright? Goodbye. See you later.